Okay, March 2nd, 2011. We're going to take up question 12 from page 100. It was last night's homework. So, 12a. The question says to choose a pair of integers for b and c. So they've given us arbitrary variables that will make each statement true. So our 12a says we need the statement x squared plus bx plus c. So we'll do the b and c in red. Bx plus c. So we need to find a pair of integers that is going to make this factorable so that we can factor this, but we will not be able to factor x squared plus cx plus b. So there's going to be numerous ones. You guys only had to find one pair of B and C. So what that means is for our first set here, because we learned the quick way of doing it, we need a pair of numbers that are going to multiply to C, and they're going to add to B. So we have to choose numbers for B and C. We haven't done that yet. Those same numbers will not be able to work this way. We need them to not equal B. When they're multiplied together, or they need to not equal C when they're added together. Okay? So if I put a line through an equal sign, that means does not equal. So we're just finding any arbitrary numbers right now. Okay, since nobody's got a pair right now, let's start at a very basic number. Let's go for the number 1. We're going to call B and C number 1. Okay? I'll do this in blue. No, sorry, black. So if I call C equal to 1 and B equal to 1, is this going to work? First of all, I'm going to need a pair of factors that are going to multiply to 1. So we need a pair of factors that are going to multiply to this number 1. What two numbers are going to multiply to 1? 1 and 1. Good. Glad you guys picked that one up so fast. 1 times 1. If I do the exact same thing with B, 1 plus 1, are they going to work? No. So these two numbers, 1 and 1 for B, they won't work. But what if we do B as 2? Is it going to work that way? Yeah, it'll work that way. So if I give C 1 and B 2, this will become factorable. This will work fine. So let's actually go ahead and try it. So I've given squared, we're given B as 2. Oh, why did I put equal sign? Sorry. Plus 2x. And we gave C the value of 1. This is factorable. We know that 1 times 1 is going to be 1, and 1 plus 1 is going to be 2. So our two factors are going to be x plus 1 and x plus 1. Works out great once we factored it. Now what we have to do is use those same two numbers. 2 is our B, and 1 is our C. We're going to plug them into the other equation where it said x squared plus C x plus B. So we're going to sub them into this, and we've got to make sure it doesn't work. We need a pair of factors that don't work. So we're going to try it out. If it does work, we're probably going to have to find another pair. So for B, we'd use the number 2. So we're going to plug in the number 2. We used it back here. We're going to plug it in for B over here. And for C, we had used the number 1 over here. So we're going to plug the number 1 into here. Now we're going to try to factor this expression. Can we get two numbers that are going to multiply to 2 and add to 1? Multiply to positive 2 and add to 1. Okay, let's try 2 times negative 1. Sorry, plus negative 1. Yeah, you're right. That's going to add to 1. But when we multiply those two, are they going to equal positive 2? No. So it doesn't work that way. Is this pair factorable? No. So we've already found a pair. Pretty early too. We could have kept going up with these numbers. Maybe C is 3, 4. You could try any numbers for these. They just wanted you guys to find 2 that would work for our first equation, so they factor in our first, but wouldn't factor in a second. So this is not factorable. Two is I'm going to write B down, but you guys can try it yourself. So they wanted x squared plus b, x plus c. They want you to find factors for these, and it also needs to work. Okay, so the opposite idea is it also needs to work for this. So they want you to find a pair of numbers that's going to work in the first equation, the factor, and the second. Matthew, what did you say you had? Okay, so let's say b is equal to 4 and c is equal to 4. Our equation now looks like this. Is this factorable, Matthew? Or is it factor in 2? 2x and 2x. So 2 times 2 will equal our 4, and 2 plus 2 will equal our other 4. So that's definitely factorable. And luckily, when you reverse them, they're the exact same numbers. So on the other side, it's absolutely, there's no difference. We're asking the exact same question. So we already know it'll work. We factored this. When we reverse them, B was 4 and C was 4, they're the same numbers. So when we reverse them, it's still the exact same question. We know it's going to work. So that's a good way to get around it there.